Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Codes, DTC P281D and P281E, are specific indicators that point to issues with the Shift Solenoid Valve Output, more specifically, the Pressure Control Solenoid H. These codes are generally related to the electrical control circuit rather than any mechanical faults within the vehicle's continuously variable transmission, CVT. Understanding these codes is vital for accurate diagnosis and repair. The DTC P281D refers specifically to a low-voltage issue in the control circuit for the Shift Solenoid Valve Output, while P281E indicates a high-voltage issue in the same circuit. Both DTCs can significantly impact voltage delivery to the solenoid, affecting gear shifting and overall transmission performance. To effectively resolve these codes, a well-structured troubleshooting process must be followed, focusing on the electrical system associated with the solenoid. The errors represented by DTC P281D and P281E specifically point to faults in the Shift Solenoid Valve Output, particularly the Pressure Control Solenoid H. The Pressure Control Solenoid is a critical component located within the transmission system that plays a vital role in regulating hydraulic pressure for optimal shifting. Located within the continuously variable transmission, it ensures that the vehicle shifts smoothly and efficiently. An issue here can lead to poor driving experiences, such as harsh shifting, or, in severe cases, no shifting at all. Given that these codes relate exclusively to electrical circuit problems rather than mechanical issues, they require a focus on the connections and wiring associated with the solenoid and the Transmission Control Module, TCM. The importance of resolving these codes cannot be overstated, as they can directly affect vehicle performance. The underlying causes for the issues reflected by DTC P281D and P281E primarily stem from electrical problems rather than mechanical ones. One common cause is the presence of poor connections or loose terminals between the Shift Solenoid Valve Output and the Transmission Control Module, TCM. Such issues can lead to either insufficient voltage reaching the solenoid or excessive voltage, triggering these specific DTCs. Additionally, shorts in the wiring, where a wire inadvertently touches the vehicle frame or other metallic parts, can often lead to a low-voltage condition, causing P281D. Conversely, an open circuit, where a wire is broken or disconnected, can create a high-voltage condition, triggering P281E. Understanding these causes is crucial in diagnosing the problem accurately and ensuring a successful repair. When dealing with DTC P281D and P281E, several symptoms may manifest in the vehicle's operation. One notable symptom includes harsh or delayed shifting, which occurs because the Pressure Control Solenoid H is not receiving the correct voltage to regulate fluid pressure in the transmission effectively. This can lead to a jerky driving experience, making the vehicle uncomfortable to drive. Additionally, drivers may experience an overall loss of transmission function, which may even prevent gear shifting in serious cases. These symptoms can present a variety of driving difficulties, from reduced performance to safety hazards. Hence, if these symptoms are observed, it becomes imperative to conduct a thorough diagnostic process to identify the underlying electrical issues linked to these error codes. The first step in diagnosing DTC P281D and P281E involves establishing that the issue is confirmed and then performing a series of preliminary checks. Start by turning the vehicle to the on mode, which activates the electrical systems but keeps the engine off. Following this, use the Honda Diagnostic System, HDS, to clear any existing DTCs. After clearing, The next critical part of this step is to conduct a test drive under specific conditions. These conditions involve starting the engine, shifting the transmission to D position, while pressing the brake pedal for at least 30 seconds. For P281E, the test drive process includes additional steps, such as shifting to P and turning the vehicle off before starting it again. This series of tests will help confirm if the fault reappears, aiding in isolating the problems related to these DTCs. The second troubleshooting step centers on determining where the potential failure may reside within the system, particularly focusing on the TCM, or Transmission Control Module. First, ensure the vehicle is turned to the off or lock mode for safety. Next, disconnect the TCM 50P connector, which allows access to the electrical terminals you will be measuring. With the connector secured in its disconnected state, measure the resistance between test points 1 and 2, where test point 1 is on the TCM 50P connector number 6, and test point 2 is connected to the body ground. The optimal resistance should read between 10.6 to 13.5 ohms. If that range is not met, it suggests a need for further investigation, either to replace the TCM or check the wiring leading to it. In the third troubleshooting step, you'll be checking for shorted wires, particularly in the shift solenoid line. Start by disconnecting the shift solenoid valve OP2P connector to ensure that you are focusing solely on the solenoid wiring. With the vehicle still in the off mode, use a multimeter to test for continuity between test point 1, which again is TCM 50P connector number 6, and test point 2, representing the body ground. If continuity exists, it indicates a short to ground in the wire connecting the shift solenoid valve output and the TCM. This scenario requires immediate repair of the shorted wire. If continuity does not exist, the wiring itself is considered intact, and you will need to replace the shift solenoid valve OP as it indicates a failure in that component. The final troubleshooting step involves checking for open wires specifically in the SOLC SHC Plus line. Again, disconnect the shift solenoid valve OP2P connector and ensure that the vehicle remains in the off mode. The next step is to measure continuity between test point 1, located on the female terminals of the shift solenoid valve OP2P connector number 1, and test point 2 on the TCM 50P connector number 6. If continuity is present, this means the SOLC SHC Plus wire is functioning correctly. Consequently, the shift solenoid valve OP itself will need to be replaced. However, if no continuity is found, it suggests an open in the wire between the shift solenoid valve OP and TCM, necessitating repairs in that wiring to clear the faults indicated by DTC P281D and P281E. After completing all necessary repairs and replacements related to DTC P281D and P281E, the final repair verification is essential to ensure everything is functioning correctly. Begin by clearing any outstanding DTCs using the Auto Diagnostics System, HDS. Once cleared, undertake a test drive to put the vehicle through various conditions and shifts, which will allow for any issues to surface if they still exist. Pay close attention to the vehicle's shifting performance during the test drive. It should ideally shift smoothly without any harshness. Finally, after the test drive, revisit the HDS to confirm that no new or pending DTCs are present. If all systems check out, you have successfully resolved the issues associated with the shift solenoid valve. Preventive maintenance plays a crucial role in ensuring long-term reliability for the systems affected by DTC P281D and P281E. Regular inspections of the vehicle's electrical systems, can help in identifying potential issues before they escalate into major problems. Monitoring the performance of the transmission during routine drive tests will also ensure that any irregularities are caught early. Scheduling timely diagnostics, especially after experiencing unusual shifting, can aid in troubleshooting efficiently. This proactive approach minimizes the likelihood of encountering issues with the Shift Solenoid Valve Output, keeping your Honda Accord performing at its best and providing a safer driving experience. In summary, understanding both DTC P281D and P281E is essential for diagnosing issues related to the Shift Solenoid Valve Output in your Honda Accord. These diagnostic trouble codes indicate electrical circuit problems rather than mechanical failures, making it critical to focus on the wiring and connections involved. Identifying symptoms such as harsh shifting can assist in directing your troubleshooting efforts. Following a thorough step-by-step process enables an effective resolution to these codes, ensuring the transmission operates smoothly. Finally, implementing preventive maintenance strategies guarantees the longevity and reliability of your vehicle systems while enhancing overall driving safety. Please like and subscribe to the channel. See you next time!